The law of cosines is really good for working word problems, so let's get some practice with this. A boat leaves port, travels 10 miles, turns 20 degrees, and travels another 8 miles. How far is the boat from port? Those are probably nautical miles, but we can oversimplify a little bit here. So let's draw ourselves a port. Okay, so we'll say this is port, and we're going to travel 10 miles. And they don't tell us what direction, and it turns out not to matter. So I'm just going to draw, let's say we went this way, 10 miles. We sail 10 miles, and then we turn 20 degrees off of our course. So I'm going to kind of do a hypothetical dotted line if we were to keep going, and we're going to turn 20 degrees off of that course. And again, it doesn't tell us which way. It ends up not mattering whether I draw the triangle above that dotted line or below. We're going to have the same length for the third side. So I'm just going to go 20 degrees, say this direction, and we go 8 miles. So we'll say this is 8 miles. So now this is where my boat is, and we want to figure out how far away we are from port. So we want to draw the best we can, a straight line between port and where the boat ended up. So you can imagine if I had gone 20 degrees above that line, this triangle would just be flipped upside down. We'd have the same distance between port and boat. All right, so we're looking for this side length. Let's give this a name. I'm going to call this side length A, which means that this has to be alpha. And then it doesn't matter which side I call length B or C. If I pick this to be B, 10 miles, that means that this little angle over here is angle beta. That means that 8 has to be C, which means this is going to be my angle gamma. And we want to find side length A. So remember that we had 3 different versions of the law of cosines, one that started off with A squared, one with B squared, one with C squared. And remember that on the other side of the equation on the right, the angle that shows up is the angle that's across from the side length on the left. The only angle I have any hope of figuring out right now in this diagram is angle alpha. We have no information about beta or gamma. So I need the version of the law of cosines that has alpha over on the right. That means I've got to start off with side length A. So I'm going to write down my formula. A squared equals B squared plus C squared minus 2 times, repeat the first 2 side lengths there, B and C, cosine of the angle across from A, which is alpha. All right, and alpha, you can see from my picture with that dotted line, alpha and 20 degrees are supplementary angles. They add up to 180 together. So I can just do alpha is equal to 180 degrees minus 20 degrees. So it's 160 degrees. All right, so let's see what else we can plug in here and see if we can solve for side length A. So A is what I'm looking for. I can't plug in there. B I said was 10. C I said was 8. The 10 and the 8 get repeated. And cosine of my angle alpha, which I just figured out was 160 degrees. All right, solving for side lengths with the law of cosines is a lot easier than solving for angles. It says everything over on the right-hand side of the equation is a bunch of numbers, and you can type that into your standard scientific calculator exactly as it looks. So I've got A squared. I'm just going to type in 10 squared plus 8 squared minus 2 times 10 times 8 times cosine, make sure you're in degree mode, 160 degrees. And I get 314.35. Okay, remember how careful we had to be not to mix and match those numbers. Here, we can just type it in straightforward. So check with your calculator, make sure you get the same answer that I do here. All right, I'm going to take the square root of both sides. And remember that A is a distance, so we don't need the plus or minus. A negative distance doesn't make sense. I'm going to take the square root of that number on my calculator, and I get 17.7 if I round it off to 1 decimal place. All right, and A is the side length. The other 2 side lengths were measured in miles, so we're going to say 17.7 miles. And that kind of makes sense. They've traveled a total of 18 miles, but that side length, the straight line distance to port, will be a little bit less than that. All right, that's it for the law of cosines. I'll see you in class for starting chapter 11.